Hi folks, so the question we're going to be doing today, guys, comes under the topic of developments, okay, and it is on the chapter on developments in your textbook, page 260. And as you can see, the question we're going to be doing today is based here off of the gift box. So it says here, example, a gift box is shown below. Draw an elevation in the direction of arrow A, a plan projected from the elevation in the direction of arrow B, and then the complete surface development of the gift box. Now this development is a little bit different from other developments that we have previously done, in the sense that we are actually now dealing with curved surfaces, okay? So as we can see here, obviously it's in the shape of a circle when we look down top of it, and we can see that it's curved the whole way around. So when we're dealing with curved surfaces, we actually use a different type of method, okay, to be able to complete the surface development. Previously we were kind of using, we were obviously using prisms, and we were using truncated prisms to complete surface developments, okay. They're a little bit easier because obviously we could take exact true lengths and so forth. When we're dealing with a curved surface, you have to do something a little bit different. So if I just go over to the example here, you can see if you have a curved surface, okay, essentially what's going to happen is that if you were to fold it out, if you think of holding a roll of toilet tissue, okay, and that would actually fold out. So if I just take the masking tape here, so when we look at the masking tape in the elevation view, if we think of view A here, okay, think of view A, we're kind of looking at it like that in a kind of isometric angle, and they want us to see what does it look like when we look in the direction of arrow A. So technically, when we look in the direction of arrow A, what we're going to see is that. And we know that's a curved surface, but the shape we actually see is a rectangle. And then a plan projected from above, the shape we're going to see is a circle. So as you can see here, we have a rectangle in our elevation view, and we have a circle here in our plan view. Okay, and what we have to do is a surface development. And as you can see, if you think of it like a piece of toilet tissue, okay, or a roll of toilet tissue, and if you were to roll the toilet tissue along the ground, it would leave behind a trail of toilet paper, okay. So that's kind of the idea here. Now obviously there will be a lot of toilet paper on a full roll, so here what we're going to actually be doing is essentially we have the distance from 1 all the way around the circumference to 12 and back to 1. That is kind of the distance we have to work with here for this object on the gift box. Okay, so obviously there's only a certain amount of length. Now the problem is where we were working with prisms and truncated prisms previously, we had definite lengths. Now we cannot measure technically from say 1 to 2 as a straight line, because as we can see it's a curved line. So what you do is you take the closest accurate distance from 1 to 2 with your compass. And I know now that is a curved line, but it is possibly the best way for doing that. And once you have that distance done once, you can actually step it out about 12 times. Okay, now what I would also like you to note is when we're dealing with cylinders, and that's technically what we're dealing with here, it is a cylinder, okay, and I'll just take you to this. So what we're going to be doing anyway, as I said today, is we're going to be drawing the elevation and plan of this and developing it out. So we can see the overall height of it is 36 millimeters high, and the diameter is 80, okay, so a radius of 40. So we'll come back to that in a second. So just going to zoom out there, and as you can see in the bottom left of, or sorry, the bottom right of my page here, I have just sketched in a quick cylinder there, okay. This doesn't matter what height it is, okay, and technically that cylinder there I have now actually got kind of here, okay. Literally all I did was I measured out, I think it was 180 millimeters, and I divided up into kind of 12 sections, okay. But what you'll actually notice on this one here, the one that I've created, okay, now it's not perfect obviously because I've just stuck it together with a bit of masking tape, but it'll do for demonstration purposes. But on this cylinder, as we can see, when you look straight at it, as I'm looking at it now, so as you would see it when you look straight at it, we can see there that we are going to see a rectangle, okay. And obviously you'd have a corner here up to the height, and that's your rectangle. And then the bird's eye view, when you look down top of it, we'll see a circle, okay. That's kind of the idea. So that's the shapes that you'll get. So obviously looking down on top, we see a circle. Looking straight in at the face of it, you see a rectangle. Now when we are doing a development, what we need to know is when we're working with cylinders, I have done a series of lines down along this cylinder here. And technically those cylinders, okay, are generators. Or sorry, not those cylinders, those lines are generators. And a generator is a line that helps to generate a surface. So if you think of this pen as one of those red lines here, take this pen, this red line here, and imagine it has this pen. And if I was to put the pen like this, okay, and I was to pick this as a center point maybe in here, and I was to rotate it around the center point until it came back into position. Technically what's after happening is that generator is after rotating around and generating a cylinder until it came back to its start point. So these guys here are called generators. And if I was to put them in here, so if we come down here to our 3D sketch, technically a generator is just a line on a surface, okay, and as it rotates around, so technically that line that I've just drawn in there, as that moves around, okay, it's going to move to this position, and I'll put in another one. Okay, we can see it. Essentially this line has just moved from here to here, and it is basically, it's helping to generate the surface, and it's going to go all the way around this circumference here until it comes back to its start point. And at that point then, that is technically what we have, that actually technically generates our cylinder. So when you actually split up your circle, okay, into 30-60 degrees, we're going to divide it up into 12, because the circle's overall angle is 360. So if we split up a circle into 30-60 degrees, so I'll just make little marks here, about there and there, I think that'll do it, and all going through the center. Now obviously this is on a 3D sketch, so this is just for demonstration purposes. But if I was to split up that circle, okay, and as you can see, where every one of them is on the circumference would actually give me a generator. Now I have one put here, so I'll put the other one here. Then I'd have another one there. Okay, and I might as well just put it in there. And I'd have one here as well. So, as we can see, these are all generators that are running along the outside face of our cylinder. But technically, it started with one and it just moved around into this position, this position, this position, and so on. Okay, that helps to generate our cylinder. So we're going to use that to basically help us. And the idea is, when we develop it out, you can see I've stuck it with a little bit of masking tape here, but when we develop it out, and I'll try and do this without tearing it, so there's that one released. When you develop it out, so if you think this was together like this, but when you develop it out, it's going to fold out flat like that. So it was together in a cylinder, something like that, and then as it's developed out, it'll be like that on a flat piece of paper. Okay, and as you can see, we still have our series of generators going along it. Okay, started with this one and it ended with this one as well, and as you can see, dark line, dark line. Okay, and this was just the path that it followed all the way around it. Okay, so that's what we're going to have to do. So, starting with that, and we'll go back to our question, we had a cylinder that had a height of 36 millimeters, so I'm going to keep this low enough on my page. So, I'll start off by drawing in my XY line, and it was 80 long, so I'll mark 80 there, and I'm going to need the middle, which is 40. So essentially I'm just drawing a rectangle that is 36 high and 80 millimeters long. So there's 36 marked, and I will now heavy that in. Put in my XY line. So there we have it. There is the elevation of our cylinder, and now what we have to do is the plan. So for the plan view of the cylinder, project this down, and it's going to keep a distance of 10 millimeters between my view. So starting there at the 4, mark down 40, that will give me the center. Okay, so from there, and then just to make sure that they'll match up, and they should do, that will be my radius from there to there. Okay, so very quickly going to construct my plan view of the cylinder, or in this case I should say it's a gift box. So mark it out to here, just make sure it matches up with the other side. There we have it. So there's our plan view of our cylinder. Elevation plan, view A and view B. Now, as I said previously, with the little sketch down here, what we're going to do is, using the plan view, we're going to create a series of generators to help us do out the development, okay? Because that's what we want. We want something like this, and obviously in this case it's just going to be a lot thinner, okay? This one was quite big, but it's still the same concept. So we want to create all of these lines. Now, to do that, in our plan view, what we're going to do is, we're going to divide it up into 30, 60 degrees. So through the center of the circle, I'm going to go 30 degrees through the center this way, 30 degrees through the center this way, 60 degrees through the center, and then once again 60 degrees through the center. And finally, the last one I should do is I should continue my line down to the bottom. And as you'll see, I've actually divided it up into 12 segments. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And technically, where every one of these lines, the 30, 60 degree lines, hits a circumference point, okay, or hits the circumference of my circle, technically that's a line that's running down, okay, along our cylinder. So if you remember, the cylinder was like this, but it's technically one of those lines running down it, and as you can see it in the graphic over here. So that point there, which is, let's say it's this point, that's actually signifying a line that is going down along the face of the cylinder. Okay, so that's what we would see in our plan view. So what I can do now is I can project them up to my elevation. Don't need to, but I think it's good just so we can understand and we can see what's happening here. And also, as we can see, when we divide it up into 30, 60, we get 2 for the price of 1. This point here, where it hits the circumference, will go through the same point here, provided we're accurate. The same here with the 60 degree line, it'll go through this one as well. So there we have it. Project them up. And finally, okay, so there we have it. Now what I'm actually going to do is I'm going to use labels to help me draw it out, okay? So, let's just switch out this pen here. So I'm going to use labels and numbers. So I'm going to start over here and I'm going to work my way around. And I'm going to call this point, I'm just thinking, will I start with this one or start? I'll actually start with, I'll do it like a clock, okay? And I'm going to say this is 12 up here. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we've got 12 all the way around back to 12. Technically, okay, and this is the top surface I'm working with here. So technically up at the top here I have 12. I've also got 6, okay? I'm going to just put the 6 underneath it. In this position here I've got 1 and 5. And then in this position I've got 2 and 4. And then on the outside I have 3. So as you can see, it goes 12, 1, 2, 3, 4, 5, 6. Therefore I'm going to have 7 underneath, as we can see here. Then it's going to be 8. Then it's going to be 9. Then we're going to have 10, 11, and 11 back to 12. And we can see it's matching up. Okay, so we're on the right track there with our labels. Now what we have to do is we have to develop out that surface. So I said, if you think of it as like a piece of toilet paper that was on its face and then it literally just rolled out like that, okay, it would leave a trail behind it. So what we're going to do is, with that, we're going to use that concept to help us out. So we know the overall height of the cylinder, okay, so that's the patch that it's going to leave behind there. Okay, and it doesn't matter where we start. I'm just going to pick a start point right about here. Okay, and I'm going to call that start point number 12. Okay, and technically, if you think of it, number 12, let's say it was over here. There was my 12. Should put that in dark, sorry. So there's my number 12. And technically that is a line that is running down along the face of it, otherwise known as a generator. Okay, so there is one of my generators there starting off, and I know 12 next moves to 1, which moves to 2, 3, 4, 5, all the way around back to 12. And the only way that we can actually do it as accurately as possible, as I said previously, we cannot measure obviously a straight line, because there is no straight line when we look down the plan view. But what I do is I take the distance from 12 to 1 on my compass, and that is the closest accurate distance that I can get between 12 and 1, which is going to work out as the same as 1 to 2, 2 to 3, 3 to 4, and so on. And the reason that works out is because we have divided up our circle, which is 360 degrees, and all of these have an internal angle in here, 30, 30, 30, okay? Therefore, all the distances are the same on the outside. So at 12, I have to step it out now how many times? 12 times. So if you think of it here, this is going to, once I at the 12 point up here, I'm going to mark it out, and I'm going to mark it, and look, right there, that point right there is going to be number 1. And then next point will be 2, and I'll continue on. Okay, so as you can see where this is going, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have to continue my line just a little bit further, 12. So there we have it. I'll extend out my line there now, just a little bit further, and then I'll write it in. So it's a nice easy process, but the understanding behind it is very, very important. So that 12th one was right here, and writing in my numbers. So 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, now at this point what I can actually do is, like any development, I'm going to heavy in the edges, and on this one we're actually not going to have any fold lines. We do have a top and a bottom that I still have to draw in, but I'll explain why we don't have them as fold lines in a minute. What you will have though is generator lines, which you can technically put in as your fold lines, okay? Because that's obviously where it folds out. Only obviously R1, in this case, for the give box, this folds into the shape of a cylinder, okay? But it is good to show obviously that we know this is a surface that is obviously bending around itself. It doesn't obviously bend to an angle of 90 degrees in the case of some of our prisms, or whatever angle we had. And finally, okay, that's just rushed there a little bit, but you get the idea. Every one of them is where there's a bend line, okay? Now what we also have, guys, for this gift box is we have to put on a top, which is in the same shape of a circle here, and then a bottom. Now for that, I'm going to pick, I think I'm going to go with 1, 2, 3, 4, 5, 6. Yeah, I'll do it right on the number 6, okay, because that's right in the middle. So I'm going to extend the line up and down, okay? And we know the radius is 40 millimeters. So what I can do then is, using my compass, okay, because we're just going to have a circle attached to the top and the bottom. So using my compass, I will take the radius, because it's going to be the same shape as our plan. So I'll take that radius there from the middle to 12, and from 6 I will mark up 40, and then from 6 at the bottom, because it's the generator, mark down 40. And now, using this point here and this point here as two centers, I am going to now connect up my base, which is here, and then my top, which is here. So there you have it, guys. That there is the development question based on the gift box. It's on page 260, okay? And as you can see, guys, the top was quite easy, the bottom was quite easy. It's essentially just a circle as we have over here in our plan, because technically that's our true shape. But the hardest part of this question, guys, is developing out the curved surface, okay? And it's, as you can see, it's actually not that hard, but the hardest is just the understanding, okay? And understanding that these lines here are called generators. So I should have written that in probably earlier on, okay? So just write that in there. So these are called generators, and what generators do, okay, is they help to generate the shape as they follow a path. Okay, so the path here is obviously the radius of our circle. Okay, sorry, a point on our circle that moves around the center point, okay, at a certain distance, which is our radius of 40. So as that moves around, okay, that generator helps to generate our cylinder. Okay, and then obviously our cylinder, once it's folded out, we can see it here. Okay, these are just two examples of different cylinders. This one's obviously a lot bigger, this one was a lot smaller. Okay, but the same concept. Okay, and obviously then I didn't have a circle attached on here at the top or bottom, because as we can see with the one I use as an example, this is an open top one. Okay, it's open-ended at either end. Okay, that's just a little bit of an introduction there, guys, on developing out a curved surface, in this case a cylinder. Eventually when you do higher level, you would move on to more complex shapes, and you would move on to developing out angled surfaces or angled lines, which would actually generate a cone. Okay, but in this case for the cylinder, that is how you would do it. Okay, hope you found that helpful, guys. That is the question complete there. Okay.